Okay, this is the pre-lab video for the experiment called Making Money at the Speed of Light. An interesting experiment wherein you're not really given instructions on how to complete the experiment. You have to devise the test that's required. So be sure to read the pre-lab manual before you come in. It's kind of fun, and try and think about how you'll be solving this problem. There's two things you're going to do. You're going to determine the speed of light in a coaxial cable, and for that you're given a short coaxial cable and a very long coaxial cable, and you'll find the speed of light in a optical fiber, and for that you're given a short optical fiber, and this one is easy to lose or drop on the floor, or because our tables are black it's easy to sort of not see it, so just sort of keep track of it carefully. And you're given a long optical fiber, and the long optical fiber, we're told what the length is. It's, in this case it's 13 meters. This is in units of meters. The coaxial cable has a length of 50 feet, so you'll have to convert 50 feet to the appropriate units. To send signals through the coaxial cable, you'll be able to connect the coaxial cable directly to the function generator and the oscilloscope to do your measurements. The optical fiber is a little different. It is just simply a clear plastic tube, basically. Well, it's an optical fiber. And so how do you connect that to our electronics, which read electrical signals, not light signals, is we have two things to help us with that. The first thing is an emitter. These blue guys are the emitters. They emit light. So they'll take a signal from some piece of electronics and convert it into a light signal. It's basically just an LED. And to connect that to your optical fiber, you place the optical fiber in the end of the housing, and then you screw on the cap and tighten on the cap. And you should make sure that the fiber is fully engaged and fully pushed into this device. So this emits the light, and we need somehow to turn that light signal back into an electrical signal so that we can study it. And for that we have a photodiode, also in a similar kind of mount. It'll be in a bag located beside you. You're meant to set up that part of the circuit yourself. And so again, that guy would get mounted somehow, and the fiber that comes out of an emitter would go into a detector. Now, the details of how we take an electrical signal and turn it into a light signal that has the proper quality for us, it's a bit intricate and complicated. The point is, well, it's not that complicated. The point is we have a chip which is sort of cleaning up the signal, the output signal from our function generator. So the property of the output signal from the function generator is not good enough to create these light signals that we want. So we pass it through a chip which gives it sort of a sharper rise time and sources enough current to drive the LEDs. This chip requires power to run, so it's going to be up to you to figure out how to, all the wires connecting to it are there, but it's up to you to attach power to it so that it works, so it's powered properly. And so you'll have to remember how these proto boards work, so you should think about that. And go back to experiment number 1 and remind yourself how these proto boards work. And of course you'll have your group members to discuss with as well. The circuitry required for the photodiode will be something that you'll set up yourself entirely, given the instructions in the lab manual. But this circuitry is largely there. What you'll just have to do is power the chip with some DC voltage, and you'll have to attach your signal from the function generator to this wire that's sticking up there. Now, an important note: when you're using the oscilloscope and function generator, and particularly in combination with the power supply, there's some important issues to take care of in terms of grounding. Normally, when we use a power supply, and when we have used a power supply, we've used the positive and negative output of the power supply. Neither of those is specifically referenced to ground. So there is no, what do I mean by that? There is no earth-ground reference location when you use the positive and negative output of a power supply. whenever you use an oscilloscope or a function generator, you are explicitly defining an earth ground by one of those connections. So what's different about a power supply and function generator is they're these coaxial connectors. And these coaxial connectors have an inner conductor, which carries the signal, and an outer conductor, which is the reference for that signal, the reference level for the voltage. But internal to this device, that's connected to ground. That outer conductor is connected to ground. So, I mean, you can even see it pictorially on the side of the function generator. So the point is, whenever you're attaching an oscilloscope or function generator to a circuit, you're explicitly setting some location in that circuit to electrical earth ground. Now, that's fine, it's not a big deal. The only big deal is if you hook up your oscilloscope in a certain way and your function generator in a different way, and you've defined ground at two different locations in your circuit, which may not be what you want to do. So how do you know what the ground connection is? When you're attaching the function generator, you're typically going to be using a BNC to alligator clip assembly. In this assembly, you have a color-coded alligator clips, and these colors mean something. The black is connected to the outer conductor, and the red is connected to the inner conductor. So the black on this assembly, when we connect it to the function generator, the black will define ground in your circuit. That's fine, as long as every other time you connect something to the function generator with one of these cables, you have the black in the same location as this black. All the grounds have to be in the same location. Now, for the oscilloscope, you'll be using a different assembly. You'll be using one of these oscilloscope probes, and these probes go from coaxial to two different connectors at the end. And one connector, which is this connector, you can expose, you can pull down the sheath and expose a little hook to hook onto some wires in your circuit. This connector is the inner pin, and this little alligator clip on the outside is the outer conductor, and this guy is ground. So very important when you're attaching both the function generator and the oscilloscope that this clip, which represents ground of the oscilloscope, is attached to the same electrical location in the circuit as the black clip from the function generator. If you don't do that, if these end up at different spots in your circuit, you've basically created a short circuit between those two locations. And that could spell bad news for frying the chip that you're using or some of these other devices. So very careful to make sure that the outer conductors of everything from the function generator and the oscilloscope are connected to the same location in the circuit. And if they're connected to the same location, then you should be safe from this short circuit condition. Okay, I think that is all the important information you need before you get started. But as I said, read the lab manual carefully before attending the lab. Okay, good luck.